Welcome back, everyone. Starting Unit 5 here with chemical reactions. First, a little bit of notes. Just talk about some of the things you're going to see in a chemical reaction in terms of like it being written out, and then also how we balance them will be towards the end of this here. So a reaction gives us kind of the before, so the things we start with, the reactants, and then the after picture of a reaction. It really doesn't talk. We're not going to talk too much about what happens here in the middle. So we're converting reactants and making products. So this reaction, if you were to read it, reads magnesium oxide reacts with or mixed with or something like that carbon. And sometimes it'll be specific. Sometimes it'll say solid carbon or aqueous magnesium oxide. So it might be a little more specific. But to form the products calcium monoxide and solid magnesium or whatever, if it is a little more specific than this. That arrow, so that arrow means form. It also might mean yields, produces, a few different words you might see used to kind of show you, okay, these things are the reactants, these things are the products. We will write these word equations and we'll practice that later on. So how we see a chemical reaction, like I said, it's reactants and products with that arrow in the middle. Quick definition, do you really need this? I don't know. You probably already know it, or hopefully already know it. Reactants, the things we start with. Products, the things we produce, or the things that are made in our reaction. Some symbols you're going to see. So if you see a plus sign, that just is separating compounds or elements. That arrow we said yields, produces, forms is what that arrow shows. It separates products from the reactants, where up here it just separates different reactants or different products. We talked about this with the POGL, just tells us what state of matter. That's when they're being real specific with solid sodium reacts with gaseous oxygen or something like that. AQ, aqueous or aqueous, that means the substance has been dissolved in water. Most of the time that's going to be an ionic compound, and we said when ionic compounds do that, they break apart to form ions. And then the other thing, if you see a little triangle, that's actually the Greek letter delta. That tells us that heat is being applied. You might see it every once in a while. I probably won't ask you to write that, but if you see it, don't freak out. That's just, we're heating it. So there are different ways of writing equations. The word equation, which is what you see down here, magnesium oxide reacts with carbon to form carbon monoxide and magnesium. The other one is the skeleton equation, which just shows the symbols. So it looks like this. It doesn't show how much. This one actually is balanced as well. But the skeleton is just everything just kind of laid out there. And then so usually what we do is after we write the skeleton, we then go and balance, which is what we'll talk about coming up here. So this is where you have the same number of atoms of each element. So if you have 2 carbons on one side, you better have 2 carbons on the other side of that arrow. So another example up here, word equation, hydrogen gas and oxygen gas react to form water. If we write that, okay, gas, we're being specific here. Water, we're going to assume it's liquid. It could be a gas. It doesn't really tell us up here. But that's a skeleton equation. Notice it's not balanced. So 2 hydrogens and 2 hydrogens, that's balanced. But then over here I have 2 oxygens, and here I only have 1. So it's not balanced. That's just kind of writing everything out correctly. My diatomics, I wrote water correctly. And then the balanced chemical equation going through and, okay, 4 hydrogens. And then by putting that 2 here, I now have 2 oxygens on that side and 2 oxygens on this side. So another way of kind of showing this with a different equation, so methane and oxygen reacting to form carbon dioxide and water. Not balanced over here, 2 oxygens, over here 3, over here 2 hydrogens, over here 4 hydrogens, and over here 2 hydrogens. So not balanced, as you can see here. So when we balance it, you can go back through and count and see that, hey, we have 1 carbon on both sides, we have 4 hydrogens, and also 4 oxygens by placing those big numbers out front, which we call coefficients. So the reason why we do this is Dalton told us, atoms can't be created or destroyed, just rearranged, and then also the law of conservation of mass says that mass has to be conserved. Basically, you have to have the same amount on both sides, which we'll do a lab with this coming up as well. All right, things you need to know. Subscripts. This shows how many atoms of an element are in a molecule. So a subscript is a little number. That tells us we have 2 hydrogens. There's no subscript here on oxygen, so we assume that that subscript is 1. We don't write it though, because again, chemists are lazy. I guess before we kind of move on, subscripts we do not change. I cannot emphasize that enough. Once you have written the skeleton equation and you have written it correctly, it does not change. So to get something to balance, then, we use the big numbers out front, which we call coefficients. This tells us how many molecules or how many pieces, I guess, because it doesn't have to be molecules. It could be formula units, things like that. So coefficient, big number out front. That tells me that there are 3 waters. And just to kind of extrapolate that, so really what that means is I have 6 hydrogens and 3 oxygens total when I'm counting to make sure I have the same number on both sides. All right, so rules of the game: matter cannot be created or destroyed, so that tells us we have to have the same number of atoms on both sides. The second one, like I said, subscripts cannot be added, removed, or changed. You do not mess with them, which that leaves us only messing with the coefficients. They always go in front, they never go in the middle, and then reduce when possible. And I'll show you an example here. So doing this first one, I have, and something that might help is to make a chart. So reactants, products, hydrogen, oxygen. I don't do this for all of them. If you struggle, I recommend doing this. So right now, on my reactant side, I have 2 hydrogens and 2 oxygens. On my product side, I have 2 hydrogens and 1 oxygen. Notice it's not balanced because they're not the same. So I need to fix this. So it looks like I need to fix oxygen. So if I have 2 and I need 2, well, I'm going to multiply that by 2. So that gives me my 2 oxygens there. But not only does that change oxygen, that also changes hydrogen to now 4. So that's not balanced. So I got to go back and fix that. Well, to get this to 4, I need to put a 2 there. So that is balanced like so. If I'm reading my answer in class, I'm going to read this as 2, 1, 2. You don't have to write the 1 in, though you can. Like I said, most of the time, chemists are lazy, we don't write 1s. But in class, I would read my answer as 2, 1, 2. The next one, playing the same game, go through, we look, 1 sodium, so 1 sodium, 1 sodium, 2 chlorine, only 1 over here, so I got to put a 2, but when I do that, I also change the sodium. So, okay, I got to go back and change that as well. So that one also balances 2, 1, 2, just coincidence that they do that. Next one, a little harder. I'm looking, sodium looks good, 1 and 1. Hydrogen, 2 plus 1 is 3, and I have 2 over there, so that's not right. And then I have 1 oxygen and 1 oxygen, so I need to fix my hydrogens. Now, I've done this a lot. I know odd numbers tend to kind of make things really, really difficult. So over here, I have an odd number of hydrogens. I have 3. I'd really like to get that to an even number just because it's just something I've learned through doing this a lot. So what I can do is if I put a 2 here, that gives me 4 hydrogens on this side. So now I have an even number on my product side and an even number on my reactant side. It just makes it so much easier to balance. So 2 plus 2 more is 4. How do I get 4 hydrogens on this side? Well, I put a 2 there. Let's check. I also changed oxygen then. So 2 oxygens and 2 oxygen. Hey, that's balanced. And then I also have 2 sodiums. So I need 2 sodiums here. Balanced like that. So 2, 2, 2, 1 is my correct answer for that one. And that one, you might make a mistake. So what? Use a pencil, erase, keep doing this. We really call this the guess and check method, or balancing by sight. So you're going to make mistakes. It's okay. I still do this all the time. Well, that 3 doesn't work. Erase it. Try something else. The fourth one here. Looking at this, it looks like aluminum's not balanced, so I'm going to put a 2 here, because I have 2 aluminums over here. I have 3 oxygens and 2 oxygens here. Well, I'm in that same boat. I have an odd number on one side, an even number on the other side. But I also know that, well, my least common multiple of 2 and 3 is 6. So how do I get this to 6? Well, I can multiply by 2 to get it to 6. And then to get this one to 6, I can multiply by 3. Okay, so now I have 6 oxygens on both sides, but I did just change my aluminums as well. So, okay, I do have to erase and change that to a 4. Something I didn't say is always check to see if you can reduce. A lot of times that means like divide by 2 or divide by 3. If I divide this by 2, I get a whole number. If I divide this by 2, I don't get a whole number. So I can't divide by 2. If for some reason your answer was maybe this, 8, 6, and 4, then go ahead, divide by 2 and reduce to 4, 3, and 2. You will miss points for not reducing. We always write it in the most reduced form. So make sure, go back through, double check to see if you can, divide by 2 or 3. That's usually what it comes out to be. This one, be careful as you read this. That's chlorine. Cl is chlorine. A lot of people mistake, the L's and the I's. Just be careful. All right, looking at this though. So I have 2 sulfurs, that's good. I have 2 chlorines on this side. Be careful, I have 4 plus 2, I have 6 chlorines on that side, which means I need to put a 3 here, because 3 times 2 gets me 6. That doesn't change anything else, so that's balanced like so. So sometimes you got to put numbers everywhere, sometimes you only put numbers somewhere. It just kind of depends on what kind of problem it is. And there's some harder ones, there's some easier ones, there's some that are already balanced and you don't have to do anything to, so don't freak out if you see something like that. It does happen. But other than that, that's all I have. Good luck as you start to balance. If you have questions, make sure you ask me in class tomorrow.